Hi guys, let's talk about the principle of the uniformity of nature. Okay, so in chapters 4 and 5 of the three-body problem, we find out that there's a scientist named Yang Dong, who turns out to be Ye Wenji's daughter, who has killed herself. And she's killed herself because she's performed a series of experiments with what she takes to be kind of devastating results. And what happens is that these experiments seem to have a sort of random outcome. Every time she performs the experiments, they yield different results. Different things happen. No matter how she sets up the experiment, she does it the exact same way every time. It yields a different result every time. Okay. She infers from this, roughly, that the principle of the uniformity of nature is false, and that since the principle of uniformity of nature is false, science is impossible. And because sort of science is her whole life, this is what she does. She feels like she has nothing else left to live for, and she kills herself. So this raises a bunch of questions. What is the principle of the uniformity of nature? Does science depend on it in exactly the way that Yang Dong says? And do the experiments that Yang Dong describes show that the principle is false, or they would be false? That it would be false if these experiments were conducted in the real world. Okay. Let's take those questions one by one. So, the principle of the uniformity of nature is sometimes thought to be sort of the basis for all of the practice of science, because it's thought to be the basis for our making inferences about things that we haven't observed directly. And since science requires us to constantly make inferences about things that we haven't observed directly, things that take place in other places, things that take place in the future, things that take place in the distant past, without the principle of the uniformity of nature, science would be impossible. Well, why? Why do you think this seemingly sort of abstract principle would play this role? Well, suppose that you take one very simple example. You believe that the sun is going to rise tomorrow, I think. Why do you believe that? Well, it's risen every day in the past. And, every day certainly that you've experienced, but also every day in, recorded human history. But somebody could ask, and this is a sort of a, I think sort of a cheeky or trollish question, but somebody could ask, well, why should the future be like the past? Just because the sun has risen in the past, that doesn't logically entail that it's going to rise in the future. After all, the past and the future are different things. And here, some philosophers say, yes, well, we need a sort of principle that bridges the past and the future, a principle that tells us the past is going to be like the future. So this principle, let's call it the uniformity of nature. It says that not only has the sun risen every day in the past, but the past is like the future. The sort of laws of nature work the same way in all times and in all places. So if the laws of nature are such that the sun has risen in the past, they're also going to be such that the sun will rise in the future. Okay. Similarly, we could use the principle of the uniformity of nature to make inferences about places that we haven't observed directly. You perform an experiment in New Jersey, and you assume that the experiment will turn out the same way if you performed it in New York or in Burma or on the moon or anywhere else in the world. Okay. So the principle of the uniformity of nature sort of is sometimes thought to underwrite inferences about unobserved things on the basis of our observations of things we have observed. Okay. This is controversial. It's not clear that our inferences about the unobserved world actually do depend on this principle, but some people suggest that it does, and this would explain why the principle of the uniformity of nature matters so much to some people. Maybe this is what Yang Dong is thinking, that science would be impossible without this principle, because inference into the unobservable realms of reality would be impossible without this principle. Okay, that's why some people think this principle is so important. What does the principle actually say? Well, Day, in his discussion of the principle of the uniformity of nature, distinguishes between sort of two forms that the principle can take. We could distinguish what he calls procedural uniformitarianism from factual uniformitarianism. Factual uniformitarianism says that the laws of nature are actually constant across all places and times. Procedural uniformitarianism is not a general claim about how the laws of nature work everywhere and every when. It's a sort of rule of thumb for choosing between competing theories or competing explanations. And procedural uniformitarianism says, unless you've got really good evidence to the contrary, you should prefer a uniform explanation of something rather than an explanation according to which things are very different in different times or places. Okay. We can illustrate how procedural uniformitarianism would work through some episodes from the history of science. So, one episode that Day discusses is a debate in 18th and 19th century geology between what were called uniformitarians and catastrophists. So catastrophists are people who see geological formations like mountains and rivers and lakes, and they say, how did those things get there? Well, they must have gotten there through some extraordinary event that took place in the past. Sometimes this extraordinary event was thought of in supernatural terms. God put this mountain, river, or lake there. Sometimes it was thought of in natural terms. Well, there was a giant earthquake, a once-in-a-zillion-year earthquake, or a once-in-a-zillion-year volcanic eruption, or an asteroid hit the Earth, or something like that. Okay. So those are catastrophist explanations of geological facts. Uniformitarians are different. They said, we can explain geological facts in terms of everyday processes that we can observe unfolding over long periods of time. So, for example, you might explain how a river was formed by water eroding the movement of water across the riverbed, eroding that riverbed over time. And so it just, it erodes it just a little tiny bit. Every time it rains, some water goes into this riverbed, and it erodes it just a little bit every single time. But, over 1 million years or 10 million years or whatever, that's a lot of rain. and this tiny little bit of erosion that you see every time it rains will add up over time into, a deep riverbed, something that's a few feet deep that a river could actually run through. Okay. So, procedural uniformitarianism says that we should prefer uniformitarian theories to catastrophist theories. Theories that appeal to mechanisms and laws and phenomena that we see operating in front of us in our own time and space to explain things in other times and places. So, there are all sorts of reasons why you might be a procedural uniformitarian. One of them is that uniformitarian theories are generally going to be simpler than catastrophist theories. A catastrophist theory sort of requires you to sort of introduce sort of new explanatory mechanisms. And, a theory that uses fewer explanatory mechanisms, a theory that doesn't require, God as an explanation, but can explain things just in terms of erosion, for example, is going to be simpler than a theory that does require God, that does require some additional sort of mechanism or type of explanation. Okay, so he says we have this sort of prior principle, this principle of parsimony or simplicity, which says that we should prefer simpler explanations, and the uniformitarian explanation will, in general, or as a rule, be simpler. But, and here's a big but, the no pun intended. Sometimes the catastrophist explanation is true. Sometimes there is going to be a lot of evidence that things in the past were very different from things as they are today. You know, we might, if we're explaining some geological formation, we might see evidence of a giant earthquake, or we might see evidence of an underground volcano, or we might see evidence of metals associated with some foreign object, like an asteroid or a meteor or something, hitting Earth near this geological formation. So we could have the sort of evidence we'd need to support a catastrophist explanation. It's possible to do science even when the uniformitarian explanation breaks down. That is a crucial point. Okay. So, when the principle of uniformity of nature that Day makes a very plausible case is sort of at work in the history of science. That is this procedural principle. Day thinks, I believe incorrectly, that you have to choose between factual uniformitarianism and procedural uniformitarianism, that you can't have both. I disagree. There's certainly no logical contradiction between factual uniformitarianism and procedural uniformitarianism. I just got a message that my phone is too hot, so I'm just adjusting it. Okay. There's no logical contradiction between these two principles, and I think what we really should say here is not that these principles are in any kind of tension, but that the procedural uniformitarianism is a principle that applies no matter what type of science we're doing. If we're doing theoretical physics about the fundamental makeup of reality, or if we're doing geology, or if we're doing social science, or if we're doing any type of science, procedural uniformitarianism is at work. But factual uniformitarianism, the idea that the fundamental laws of nature apply in all places and times in the same way, maybe that's just a law that's restricted to the fundamental laws of nature. It's not restricted to, or that's not restricted. Excuse me. That doesn't apply to geology, for example, which is only about how things look on planets, not everywhere in the world. Okay. Good. So, Day thinks that we should opt for a procedural version of uniformitarianism. I think we don't have to choose between procedural and factual uniformitarianism, but what, at the very least, what Day shows is that procedural uniformitarianism is a sort of version of the principle of uniformity of nature, which is at work in everyday science, not just in fundamental physics, but also in history and geology and psychology and so on, and that this version of the uniformity of nature, principle of the uniformity of nature, isn't necessary to the conduct of science. That is to say, that you could have a theory which violates the principle of the uniformity of nature, and it would still be possible to do science, even if that theory violated that principle. Some catastrophist explanations are true. Some non-uniformitarian explanations are true. The fact that they are doesn't mean that science is impossible. Okay, so maybe this can help us understand what's going on with Yang Dong. I think what's happening is that Yang Dong thinks that the principle of the uniformity of nature is sort of necessary to explain or justify inferences to anywhere in the unobservable world. Inferences to the future, inferences to the past, inferences to regions of space we haven't directly examined. I If that were true, then discovering that the principle of the uniformity of nature is false would indeed make science impossible. But I don't see either very good reason to think that the principle of the uniformity of nature actually works like this, that it's actually necessary to sort of support all of our inferences about the unobservable world. I also don't think that Yang Dong's experiments show that this principle is false. All Yang Dong's experiments show is that some physical processes are random. They don't have a determinate outcome. But that doesn't mean that all physical processes are random. If all physical processes are random, that would mean that science is impossible. But not just because at least in some sense of random, but not just because the principle of the uniformity of nature is false, but because the world wouldn't be law-governed or predictable or explicable at all. And since science is about discovering laws of nature and predicting and explaining things, then science would be false. But surely Yang Dong's experiments about some little particle accelerator don't show that nothing in the world is predictable or explainable. Okay. Lastly, Yang Dong might, if Yang Dong had adopted a procedural understanding of the principle of the uniformity of nature, she could say, okay, well, this is a rule which is important to the practice of science, but it's still possible to conduct science even when this rule breaks down. That is to say, even when we are forced by the evidence to prefer the catastrophist explanation. Okay. Thanks.